Hi, I'm Bill Kinney, and this is video number 8 in a series on foundations of arithmetic, algebra, and graphing. Video number 8, multiplication of integers, meaning and application, part 5. In video number 7, part 4 of multiplication of integers, we focused on algebra properties of both addition and multiplication, especially the distributive property. And in this video, we're going to use the distributive property, use the meaning of addition to try to motivate the rules for multiplication with negative numbers. Now, when you think about an array like this, coming back to the entire big array that we saw in this video, thinking of this as 4 times 5, when we've drawn charts like this, we realize that we can think of multiplication of positive integers as repeated addition. 4 times 5 could be thought of as adding 5 to itself 4 times. Think about these rows. You add 5 to itself, 5 plus 5 plus 5 plus 5, to get 20 dots altogether. 4 times 5 is 20. You could also think of it as 5 times 4. You could think of it as adding 4 to itself 5 times. Think about the columns now. Each column has 4 dots in it. 4 plus 4 plus 4 plus 4 plus 4 is also 20. Now that illustrates that 4 times 5 equals 5 times 4, and it also illustrates that you can think of multiplication of positive integers as repeated addition. If you think of it that way, that helps motivate the idea of multiplication of a positive times a negative. For example, let's start basic. If we have positive 5 times negative 1, what should that mean? Well, if you think of it as repeated addition, that means you could think of this as negative 1 added to itself 5 times. 5 times negative 1. Negative 1 plus negative 1 plus negative 1 plus negative 1 plus negative 1. Altogether giving you negative 5. And if you want the commutative property to still work with multiplication, including multiplication of negative numbers, well, negative 1 times 5 still better be negative 5. And that leads you to saying, you know, maybe I should, anytime I'm multiplying something by negative 1, maybe I should get the additive inverse of the number that I started with. And so, for example, maybe that should mean that negative 1 times negative 5 should be the additive inverse of negative 5, which is positive 5. Maybe that's not satisfying to you. Okay, I'm going at a purely algebraic level here. Think about that. If negative 1 times 5 is negative 5, if it's the additive inverse of 5, remember negative 5 is the additive inverse of positive 5 because when you add them you get the additive identity 0. Maybe by analogy at least, if I multiply negative 1 times negative 5, I should get the additive inverse of negative 5, which is positive 5, for the same reason. When you add 5 and negative 5 in either order, you get 0, the additive identity. Okay, well, you might be wondering, well, is that important in real life? We'll get to that. What should this mean about, say, 5 times negative 4? What should that be? Hopefully you know it should be negative 20, but why? If we're talking on a purely algebraic level, we could think of it like this. Negative 4 is, well, the additive inverse of positive 4, and as such it can be thought of as negative 1 times positive 4. And, well, the associative property for multiplication works as well as the commutative property. I can rearrange this. I'm using both the associative property and the commutative property here. I can rearrange it to look like this. Just switch the 5 and the negative 1 around, and I guess keep the parentheses there the same. 5 times 4 we know is 20. Negative 1 times 20 is the additive inverse of 20, which is negative 20. So there would be an algebraic justification for why 5 times negative 4 is negative 20, based on assuming we want the associative and commutative properties to still work, and based on saying that negative 1 times any number is the additive inverse of that number. Why should negative 5 times negative 4 be positive 20? You might hopefully recall that a negative times a negative is a positive. Why should that be the case algebraically? Well, once again, we can think of negative 5 as negative 1 times positive 5, and think of negative 4 as negative 1 times positive 4. We can, again, by the commutative and associative properties, rearrange this to be negative 1 times negative 1, say, times 5 times 4. Negative 1 times negative 1 is positive 1. Positive 1 is the additive inverse of negative 1. And 1 is the multiplicative identity. 1 times anything is that anything. 1 times 20 is 20. So indeed, negative 5 times negative 4 is positive 20. So if you're algebraically inclined, symbolically inclined, maybe these are good enough reasons for you. But I know many people are not so symbolically inclined and want some sort of real life reasons. I'll give you something here. I'm not sure if it's going to completely satisfy you, but I'll try. I'm going to come back to this picture of a person throwing the ball up in the air and letting it fall down. We use this picture to motivate real-life applications of negative numbers, thinking of the ground as being height 0 and above ground is positive height and below ground is negative height. Well, what about multiplication of negative numbers here? That doesn't seem to play a role. Well, let me cover the hole. Let me just pretend we've filled in the hole here. No hole there anymore. And so now I'm going to throw the ball up, and it's going to fall back down, and we're going to imagine this ball is a bit squishy, and it's going to bounce off the ground. Maybe the ground should be a floor instead. It's going to bounce off the ground, bounce back up, not quite as high because it lost some energy, then come back down again and keep bouncing until it doesn't bounce anymore. It turns out to be a good idea in many circumstances to think of each time the ball turns around as being in a sense a multiplication by negative 1. If we're talking about something called the velocity of the ball, which is actually different than the speed, but related. The speed is telling you how fast it's going, whether you go up or down, and speed is never negative. But something called the velocity is positive or negative. It would be positive in this case when the ball is moving upward, and negative velocity when the ball is moving downward. So the idea of velocity takes into account direction, and the negative sign indicates which direction you're going. If it's positive direction, you're moving in that upward direction, then your velocity is positive. If it's a downward motion, then the velocity is negative. Anyway, when the ball switches directions, when it reaches the peak and then starts to come down, you can think of the velocity essentially as being multiplied by negative 1. That's not a perfect interpretation of it, because actually when it's at the very top, you think of the velocity as 0. But not really paying attention to the actual speed of the ball, it is, in some circumstances, okay to say, okay, my velocity is positive here as it goes up, and then it gets multiplied by negative to indicate that it starts going down. So now the velocity is negative, and when the ball hits the ground to bounce back up again, it's like you're multiplying by negative as well to get back to a positive velocity. So that's a little indication of why, a physical reason why multiplying a negative times a positive is a negative, and a negative times a negative is a positive. It may not satisfy everybody, but I hope it's good enough for you. Maybe one other visual, at least, is if you think about a number line. Anytime you multiply by negative 1, you're sort of wherever you are on the number line, you're sort of going to the opposite side of 0. So negative 3 times negative 1, you want to visualize that as moving to positive 3, which is just as far away from 0 as negative 3 is, but on the opposite side. Do the same thing if you multiply 3 by negative 1, you go to the opposite side to get negative 3. If you adjust it correctly, you can think of this in terms of multiplying by other negative numbers as well, like negative 2. For example, 1 times negative 2, you can think of as first multiplying by 2 to get up to 2, and then multiplying by negative 1 to get to negative 2. If you get negative 1 times negative 2, first think of it as multiplying by 2 to get to negative 2, and then multiply by negative 1 to get back up to positive 2. So there's a nice visual way to think of that as well here. If I went too fast for you because this is getting long, you probably want to rewind it and watch it again and really think as I say that.